Welcome to Module 1, Lesson 8. Today we're going to be focusing on the commutative property still, but specifically on how to demonstrate it in multiplication. We'll talk about other ways to visualize it as well, but this is the primary thing we're going to be doing today. So, kind of going off of this is recognizing again that in multiplication you can swap the groups, and in each group the numbers, the factors, and it's still going to equal the same thing. So, example of that would be if I were to write up 9 times 5. Remember this 9 being how many groups, and the 5 being in each group. We can say that they equal a sentence very similar to it. And I could write this up as 5, meaning the groups, times something, which means in each group. So for this example, you should be able to look at this and recognize that 9 times 5 is equal to those two numbers swapped. So 9 times 5 is equal to 5 times 9. And you should be able to go down this line with multiple things as well. You should be able to go down and see that 3 times 6 is equal to 6 times 3. You can continue on. 7 times 4 is equal to 4 times 7. And you don't even need to really know what the answers are to still agree and understand this format. For all you know, you could go 107 times 92 and just say, well, I know it's going to be the same answer as 92 times 107. They equal the same thing. So if you find the answer to this one, you'll know the answer to that one. Don't worry, we're not going to be doing a problem like that today, so don't worry about it. Just kind of an example that it continues on and on and on, even as you go farther into higher numbers. Now, I want to visualize how this looks like in a array again. So, I'm going to use the problem 5 and 3. So I'm going to say, I want you to create 5 rows of 3. And this is the exact problem from your problem set, so if you'd like to do this one with us, you're more than welcome to. Once again, you can get there if you're not already there, and just hit pause to get there real quick. So, the very first one says show 5 rows of 3. So I'll make 5 rows. 1, 2, 3, 4, 5. Make sure that one, you can see it. And make sure there's 3 in each one of them. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now once again, I'm just going to do a quick double check, make sure I have 1, 2, 3, 4, 5 groups, and there's 3 in each. 1, 2, 3. I made 5 groups of 3. Now, the next part of this question is make 3 groups of 5. So basically saying this, but turn it on its side. And so I can go ahead and do that over here. I'll say there's 3 groups, 1, 2, 3, with 5 each in group. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And that's basically the entirety of that problem for that first part. Then it's saying, now give me the multiplication sentence for this and the next one. Once again, you start out with how many groups you have. So you go 1, 2, 3, 4, 5. So 5 times 1, 2, 3. 3 in each group. And we can go ahead and do the same thing for this other problem. So go ahead and think about it for a second. How many are in each group? You can just go ahead and look at that and go, sorry, I said in each group. So still have that number in your head, but I'm going to ask how many groups do we have for this one? You can go 1, 2, 3, and there's 3 right there. Now, since I just kind of said it already, I'm going to ask how many are in each group. And you just go 1, 2, 3, 4, 5. Creating that dynamic right here. So now we have 5 times 3 and a 3 times 5. Once again, this is recognizing that I can draw an equal line between these, saying these two things equal the same thing. They will add up to the exact same number, just because of the commutative property. So that's kind of the primary. I want to show some other examples and show you how else you could visualize or see this problem, or just something else that you might see in your homework or might see on Zern. So you might have that question. Once again, going to show you a format that you will see for a little bit here. And let's say I have 7 3s. Once again, using this format, 7 3s. It's important to recognize what this means in a sentence. You take the first number, which is a 7, and you just drop it down. Say that's 7. And you times that by the written out letter. So I have 7 3s, so there's 7 groups of 3. And then you can go ahead and solve that problem is. Another method that this could potentially be written out as is for, let's use a different number than here. So I'm going to draw a line right here saying it's different now. I have 4 plus 4 plus 4. And the question is, put this in the multiplication sentence. Now this is a very important part because multiplication is by definition skip counting by the same number in addition. So just repeated addition. So this is repeated addition. I'm adding 4 to 4 to 4. So 4 plus 4 plus 4. Now this can be rewritten in another format, and that format is multiplication. First off is you recognize how many groups you have of this. And just imagine this kind of like what we've done before. Each one of these is a group. So how many groups are there? Or in other words, how many 4s are there? There's 1, 2, 3. So there's 3 groups. And so how many 4s are there? There's 3. So there's 3 what? 3 4s. And so you put 4 right here. So there's 3 4s, which then, once again, can be translated into 3 times 4. Now, this is relatively important to understand how 4 plus 4 plus 4 can become 3 4s, and 3 4s can become 3 times 4. Meaning that these two things, 4 plus 4 plus 4 and 3 times 4, is the exact same thing. Now, as this continues on, I can give more examples. I can say 6 plus 6 plus 6 plus 6. I can say, how many groups do I have? I have 1, 2, 3, 4. So I have 4 groups of 6. So I have 4 6s. And then that can translate to 4 times 6 as well. And this, once again, continue on and on for multiple examples as well. In addition to this, I do want to explain a little bit about multiplication, because typically, as we visualize multiplication, 9 times out of 10, we view it like this. 2 times 4 equals something. That's the typical format that we view these in everyday life, because usually we have this many groups, how many are in each group? Now, this can be flipped on its head a little bit. I could instead say I have 8 and 2 times what equals that? Now, this might look a little confusing at first, which it does. It does look like, wait, I don't understand what's going on. That's fine. It doesn't matter which side that equal sign goes on these equations, because all it's saying is 2, like up here, 2 times 4 equals something. If I wanted to, I could put that over here. Equals something. It's fine. I'm just saying this. It's an equal sign is defined by saying the left side and the right side are the same thing. So this is saying it's 8. So what do I need to do over here to make this side 8? And you can do that by skip counting by 2s until you get to 8. So you can go 2, 4, 6, 8. And you find out that the answer is 4. So 4 or 2 times 4 equals 8. And look at it. It's basically the exact same format as right there. And that's fine. That right here and this one up here are stating the exact same thing. 2 times 4 equals 8, and 8 equals 2 times 4. Exact same problem. Just keep that in mind. Exact same. And this bottom one is a really good example of how I've mentioned that division is basically multiplication backwards. Let me show you what I mean. Let's get you the problem. Let's say let's go 9. Actually, I don't want to do that one because that might throw someone off real quick. So I'm going to say 15 equals 5 times what? Now this thing, I have 15 of something. If I split that into 5 groups, how many are in each group? Or you can visualize it as 5 times what equals 15. And you can skip count by 5s and you get to 15. So 5, 10, 15. So the answer would be 3, since I did 5, 10, 15, and there's 3 fingers I'm holding up. Now, once again, that might still be like, well, how is that like division multiplication backwards? Let me write this as a division problem, and you'll kind of see what I'm talking about. if I have 15 and I divide it into 5 equal groups, how many are in each group? Now, they might look a little bit similar now. This is division, this is multiplication. Equal signs are a different spot as well. But watch this. I can say 15 divided by 5 equals what? Or I can say what times 5 equals 15. You can do that. You are allowed to do that. That's not cheating. That's just using a math strategy. I use that all the time still. I'm always like, well, 30 divided by 5 is what? I don't remember what that is. So anyway, but 5 times what equals 30? You can go 5, 10, 15, 20, 25, 30. So 6. So the answer would be 6 for that one. You can do the same thing here. So without giving an example with the answer already up, I could do 20 divided by 5 equals what? And you can go, what times 5 equals 20? So we can go ahead and do that. And we can go 5, 10, 15, 20. So 4. And we can double check ourselves on that. We can do that in a couple different ways. Let's do it in the division way and the multiplication way just to show that there's a dynamic here. If I have a total of 20 and I have 5 groups, so 1, 2, 3, 4, 5, how many would be in each group? And so, just as a strategy I've used before, we'll drop 1 in each continuously until I'm out of 20. So if you'd like, you can go ahead and count with me at home. You can go 1, 2, 3, 4, 5, back to the beginning, 6, 7, 8, 9, 10, back to the beginning, 11, 12, 13, 14, 15, back to the beginning again, 16, 17, 18, 19, and 20. I'm out. I've hit the 20 now, so I don't do any more ticks. And I can look at these and see that they all have the exact same amount in them, and we can just count them up. 1, 2, 3, 4. So there's 4 in each group. Once again, you can try it the other way with the multiplication. Say, does 4 times 5 equal 20? You can do 4 groups. 1, 2, 3, 4, with 5 in each group. 1, 2, 5. I'm going to do that just real quick for you. And that should add up to 20. You go 5, 10, 15, 20. So either one of those methods works, so just kind of keep that in mind. There are multiple strategies to solving problems. That is a thing. The only concern with that is make sure that you're still following the same rule. As long as you're following the same rule, you're golden. So just kind of keep that in mind. The main idea of this entire lesson, again, is recognizing that something like 2 times 4 is the same thing as 4 times 2. That is the commutative property, or the commutativity of multiplication, as you can also call it. So that being said, have a good day.